So to those of you who have turned up this morning, good morning. I hope you had a good night last night. It looks like a few people had too good a night and they're not here. It's a standard conference thing, so get used to it. So my name's Addison. I'm a developer at Technology One, a graduate developer at the moment. I only started there in January this year after graduating from here at the end of last year with a software systems and aerospace engineering degree. If you want to contact me, there's details up there. So what I want to talk to you today is about our software service, which is software as a service platform, our cloud platform, which we are trying to get more customers to move over to. So one thing that's really big at the moment is the cloud. Probably to you, the cloud has been a buzzword about 2 years ago. In the enterprise, it's now going on to be a big buzzword now. So for us, that's a big thing that we're trying to push to our customers. So what I'd like to talk to you today about, firstly, some of the challenges that we face with software as a service, which you can probably relate to with all of your own projects as well. And I'll go into some general developer tips that I think would be useful to you to think about when you're doing your development, things that I've seen while I've been tutoring here at UQ, as well as things I've seen at work and other projects that I've done. So at Technology One, we are an enterprise software company. We're making our CI Anywhere platform at the moment. And the aim of that is to have one platform that can work anywhere on any platform at any time. So that means I can pull out my phone right now, as Matt did yesterday, and open up our software and do every single thing that I could do on the browser in my desktop. Now, that's a big thing for enterprise software now. We're trying to push that as hard as we can, and our customers are really enjoying it. But one thing that we need to be able to do once we've got that is able to access that from anywhere, and that's where the cloud comes in. So the Technology One cloud, we have our own cloud. Basically, we are running our software on AWS EC2 instances, and all of our customers, if they want to, can become a cloud customer, which means that we manage all of their services. Now, traditionally, all of the software is going to be installed on their premises, and they are looking after it, and they're just getting updates from us. Once we start hosting it, it's a little bit different. That means we are in charge the whole way, so we need to make sure, obviously, that it's working as well as it possibly can. So there's a few things that you have to think about when you start doing cloud software. First one is scalability. How are you going to make sure that every single request that comes in at any point in time is going to be serviced as soon as it happens? So that's a challenge that we have to face. That's something that's somewhat easy to do once you get it started going. But one thing that if you develop in old models where you're trying to just build one little app and have it scale across lots of different people at once from one box, that's just not going to work. So with CI Anywhere on our cloud platform, we can basically have it set up with our Cloud 5 system. So we've gone through multiple iterations of our cloud system. Version 5, we can just spin up a new instance at any point in time. It's behind a load balancer. It's got all our software on it, and it's just ready to go. Now, for Cloud version 3, we could do that as well. We could set up a new instance, install our software, and then we'd have to configure it. Now, configuration is the most annoying part of any of this stuff. And as you can imagine, when you've got lots of people using your cloud, for our enterprise system, we have to have config for each individual client. And that meant that we had to go and configure individual instances for different clients and stuff like that, which was really not the way to go. So with Cloud version 5, they've changed things quite a bit. So we now have, as they call it, config as a service, which really helps out. And that's done basically that we can deploy an instance which has no config on it at all. It just knows to go to a server and get all of the configuration, such as the database connection strings and all of the other configuration that you possibly could need for a particular client based on the URL that they've typed in. So if they are customer A doing a request, comes in, goes off to our enterprise app store, as it's been called, gets the config for that particular customer, then configures the environment, loads up the page they want, and there we go. We've served their request. But that's been quite a long time coming, quite a bit of challenging stuff done to work that out. And it's mainly due to the way that our software is done. So there's a lot of things that you can do now. If you're doing a Node.js client, as a lot of you like to do, and I've done it as well in my personal stuff, or Python or whatever else, you can go and develop your app a bit differently, so it's much easier. You don't need the config as a service as such. But with our .NET framework, it's been a little bit harder to scale that across, and so we've gone the config as a service route. The other thing I've got up there is our distributed processes. So within our application, we have a piece of functionality which basically means that we can schedule jobs to run at any certain point in time. So it's just a task queue. Now, traditionally, that was installed on a client site. We have one of these DPs or a couple of these DPs running on their site. The jobs go off to them, they get run, and so on. Now, in our first cloud structure, we actually had 2 distributed processes installed per client. So that was a lot of boxes sitting there just to run these distributed processes. It's a lot of money involved with that and a lot of resources that we need to set up. So what we found was that once we went to the cloud and we've got everyone sitting in the cloud, it's much easier to simply have a single queue that services all clients. So we've now got one distributed processor queue for our cloud DP, and that will then automatically spin up extra nodes as the number of jobs increases. So we can basically turn it on, forget about it, because if there's a large number of jobs, it just automatically goes and spins up a new node and services all those requests. Once the number dies down, we can turn off a couple of those nodes and save a bit of money. So the other thing that has come out of this project is a monitoring project. So if you're doing any sort of software, you need to be able to monitor that software. There's no doubt about it. You need to have logging at every single possible point you can, because if you are deploying to a customer or you have stuff in production where you are following certain standards that we are and so on, customers do not want you to just go and touch their database at any point in time. Like, as a developer, it's really nice to just go, oh, there's a problem over there. I'll just go and connect my development environment up to their database, and I'll see what's happening. You can't do that. It's just not possible. So the only way to get around that is to have really good logging and monitoring throughout your entire system. So within CI Anywhere, we log all of our service calls. So that means that if someone is trying to access any part of one of our entities within our software, everything to do with accessing that, whether it be reading, writing, saving, whatever it might be, we are going to log that call. We're also going to log every single SQL statement that is performed in our product so that we can see exactly what happened at any point in time. Now, I'm not going to say that we've got this right yet, because we really haven't. Our products, currently, we can see a lot of information, but there are still many times where we are getting errors and we cannot exactly work out where it's happening, because it gets to this point and it's sort of going all right, and there's something after that. But we are working on that now, and I highly encourage you, when you're writing software, to think about all the logging from the first place. Because if you don't do that, you'll have to go and retrofit it, and that's really annoying. So within our cloud environment, we have all this monitoring from CI Anywhere, and one of our cloud team members decided that they would set up a new workflow for all of this monitoring analysis. So we've now got a system set up whereby we collect all this data using a whole number of Amazon Web Services tools. So if you go and look up their site, there's so many different tools that you can use. It's really fun to check them out. So first thing we do is we get all of the log data coming out of our system, and that's going to be pushed into Amazon Kinesis. So basically, it's just a big pipeline, if you want to think of it like that. All the data goes in, it can sit there for a while, and it'll go out eventually to wherever you put it. So in our case, we have a Lambda function, which is really just a Node.js script that's going to run. And we are using that to pull the data out of Kinesis and push it to 2 places. So the first one, we're going to push that into S3. So we've got a backup of that all. And then the next one, we push it to our visualization system, which I'll show you in a minute. So once it's in the visualization system, that's it. It's now visualized, and you can go and look at it and play around with all that. But the more interesting part comes down to when you've got the stuff in D3. So we're using, from step 3 to 5 there, we actually use Apache Pig, which is part of the Hadoop project. So we do elastic MapReduce operations over it all. I haven't looked into exactly what they're doing in that because I'm not part of the cloud team, but I'm sure that they're doing some interesting things in Hadoop, and I have seen it happening. So the pig setup that they've got is going to pull the S3 data in and then do all of the operations on that. Following that, we're going to consolidate all the data that it's generated and push that back to S3. Then we pull that out again, and we can use things like Hive to go and do SQL-like queries over all this big data that we've got in our data lake. So as an example, a bit of a busy diagram, but we've got over there on the right-hand, your left-hand side, we've got our cloud setup. So we've got our databases, our DPs, our web server for CI Anywhere, and so on. So as you can see, all the logging information goes up the top into Kinesis, and we use Lambda. That raw data then goes into S3, which can go across into Pig. Consolidated stuff comes back to S3. We pull that again into Hive, and then from there we can go into our relational database if we need to, or use ad hoc inquiries through Hue and stuff like that. There's also our database up there, InfluxDB, which we use to power all of the live graphics. So, as an example, we have there our insights into our 2015 B release. So we did a release in about July this year, and we've pushed this out to our cloud systems for all of our consultants and early adopters and our internal staff to use. So we've done a whole lot of statistics around that. Like, this is only the start. I'm sure that they haven't worked out exactly what they want to do with all of it yet, because we haven't had the data before, and there's so many interesting things you can do with the data. So from this, we can see user wait times. We can see exactly how long requests are going to be taking. The data at the moment is really not that wonderful, because on the weekend, I don't think many people are actually using it today, so you'll find that the data is pretty static. But during the weekdays, and we go and look at the screen, it's a lot more interesting with a lot more spikes in the data to see exactly which apps are going slow and which ones are not performing as well as we could. So we use the data from this and out of our Hadoop cluster to go and do things such as earlier warning systems. So if we can detect that there's a problem in one of the apps, we are going to go and fix it, because our customers don't want any errors to show up, and we don't want those errors to appear either. So we go and do warning from that. We can also give all of the analysis to our individual product teams, so they can go and see what their apps are performing like and try to optimize that as much as they can. And then we also get all the nice visualization. Now, a slightly different aspect of moving to the cloud and moving to web-based systems that I want to touch on is data integrity. So one thing that I found a lot of people don't really think of is the fact that when we had our desktop client, so our old VB.NET client, which is out of date now, and that's why we're building the new web stuff. So all of that was done as a desktop app, which meant that the service calls to go and access entities, save them to the database, and so on, that's all happening within the application. So unless you want to go and hack our application and exactly work out what's happening inside it, it's much harder for you to get to the data to access that, to manipulate it in any way, shape, or form, apart from using the screens that we provide to you. Now, when we've got our software as a service or our cloud-style infrastructure, basically any installation of CI Anywhere, all of the requests are made from a GUI on a web-based client to our server, which means that we're doing lots of AJAX requests. That means that all of those endpoints are exposed. So as you can understand, you need to make sure that you are properly validating all the data, and you don't want to accept things from people that you don't know about. So sure, you can lock it down so that only certain people can access certain areas of the site, but even if you open it up so that person A can access this particular web service, well, what happens if they push the wrong type of data in? A lot of people think about doing validation of all the data in the GUI side, and that's really good. You can show errors straight away and say, fix this up, and no, this is not acceptable. But who's to say that someone else who's calling your web service and sending you data is going to perform the same validation in their client? Basically, you can't guarantee that. So you need to remember, and even teams within Tech 1 need to remember, that when you have all this data available and all the web services open to anyone, all the validation that you do in the client needs to happen in the business layer as well. So when you actually have all the logic there in the back end to process all your data, you need to validate every single part of it. Another thing that people don't think about with data, time zones and dates. They're wonderful. So as you know, today is the start of daylight saving because it's the 4th of October. So at 3 a.m. down south, because we're backwards up here in Queensland, they all went forward an hour and we're still stuck in the past or something like that. So that throws up another challenge because let's say that we've got all of our servers hosted at Amazon down in Sydney. We have clients up here in Brisbane and stuff like that. And if you're doing your own projects, you'll probably have some sort of data set up somewhere, and I'm sure you've got a date in there. If you don't, I'd be really surprised. But people don't think about these 3 points. So what time zone is my current time zone? What is the time zone of the server, and what is the client's current time zone? And finally, if we're having these things like web services, how are they going to interact to send dates through to me? And how am I going to process them? Now, at Tech 1, our date setup I really don't like because it was done a long time ago when we had customers in Australia, and that was it. Now that we're branching out all across the world, that's really going to be biting us for a long time to come. So one thing that you should think about doing with time zones is using a standard format. There is an ISO standard for dates. Use it. If you can accept those date formats, then you can exactly work out what time zone someone is sending you a date in, and you can send the date back in the time zone that they want it, and then things will just work. And when you're storing dates in your database, use UTC time. I don't care what time your server's in. I don't care what time your database server's in. I don't care what time zone you live in compared to what my stuff is in. I'm just going to store that in UTC time, because if I know it's in UTC time, I can tell you exactly what time it is, and I can convert it to your time zone, or you can do that for me. I don't care. As long as I know exactly what time zone it is, and UTC allows me to do that, then we can go and do things much more simply. So please, when you're doing time zones and dates, think about that from the beginning and do it properly. So that's sort of things that have come up from our cloud infrastructure and our CI Anywhere thing and expanding globally. Now, these are some things that I want to talk about to you as developers that I've noticed people aren't the best at doing from my time here tutoring for courses like CSC 2310. I'm sure you'll all know about that. And also people at work and stuff like other open source projects I've worked on and stuff like that. So these questions I'm going to cover a little bit today. So have I tested my code thoroughly? Can I prove that the code was tested? So for example, with our products at Tech 1, we cannot release any of our apps unless there is at least 60% code coverage for that particular piece of code. So 60% I think is actually quite a low number. We should be going much higher than that. But as a start, okay, good, we've started off, we will get there very soon. But do that for your own projects as well. 3, is the software simple enough for any user to use? I'll touch on that soon. 4, are there resources for developers and users to work out how to use your software or APIs? And 5, is the code safely and reliably stored? So, testing. Quite simply, you need to test your code. The number of times I have seen people write code and go, oh yeah, it's all fine, I know it works, that's good. Yeah, sorry, it breaks horribly when I try to do X thing on your software, and you should feel bad and you should go and fix it. If you'd actually wrote a test to test it properly, like we said in the spec for that particular piece of code, you wouldn't have a problem. Now, as software developers, we've got lots of tools available to us. Every language has got some sort of test system. So C# that we use has got its unit testing thing. In Python, there's unit test, which is included with Python, and you can use that. In Node.js, I haven't actually done testing much in Node.js because I haven't used Node.js much, but there'll be something in there too. Every language, there is some sort of test framework. Go and learn about it and use it. If you aren't using it, you should be. So by doing these automated tests in such frameworks, we can do things like every time we build our software, we will run the tests automatically, then we can generate code coverage and see how much of our software is actually being covered by those tests. People write tests and go, oh yeah, I've covered all this functionality. They'll then go and check the code coverage and go, oh, that's only 1% of my code. Oh, what happened to the other 99% of it? Well, you just need to write more tests. Now, the other thing is UI testing. As people who are doing user interfaces, you'll know that testing a UI is hard to test apart from having someone sit in front of it and click a button and check that every single thing works. So we, on every single team at Tech1, have got a tester dedicated, sitting there, testing our code and finding problems with it. We don't want them to find problems with it, but it's much better for us to find it in-house than to ship it out to customers and then have to deal with a whole lot of P1 cases where we need to fix it up. So we can automate some of the testing. There are things like Selenium and so on that can do that. The problem is that as you go through and do lots of development, we find that our platform team might change one ID of something to fix a bug, and then all of the tests would then break. So yes, you could go and fix it up, and you have it then to work again, but there's a lot of time to upkeep all of the UI tests. So you can automate some part of the UI tests, but I think you still need someone to sit there and physically test it. And I don't think that person should be you, the person who wrote it. Because you go, oh yeah, I know I can click this and this and this and expect things to happen. But as soon as you put someone who's never actually used your software before in front of it and get them to start pressing buttons, that's when you see everything blow up and you find how badly it's actually written. So give it to your friend. Say, look, here's my wonderful new app. I want you to go and test it. I want to see how good it is. Please tell me what it's like. And in an hour's time, they'll give you a list of 1,000 things that are wrong with it. So, for example, one of the apps on the team that I'm on the business process management team, so we do workflow. This is a simple visualization of the code coverage from the last build. You can see that we've only got 68% covered in that app, which is not really high enough. But we can drill down into that and see exactly what parts of the app need work. So the darker bits over here look like they need a bit. So yeah, that one there, 0% covered, that's not very good. So tomorrow I should be going and saying to the developers, okay, see this big red circle, it needs to be fixed. And they should then go and fix it. But tools like this, so someone at Tech1 just wrote this up because they wanted to play around with F# to learn some functional programming. So they did that and then used D3 because D3 is really cool for visualizations. And they threw this together and anyone in our workplace can then use it. So that's just pulling all the data from the automatic code coverage that's done with each build. So testing, really important. Please do a lot of it. And a really good way to get involved with testing, if you aren't sure, go and look at some open source projects. So like if you look at Django or Python, because I am a big fan of both Django and Python because I did a lot of Python development before going to Tech1. So if you go and look at their systems, they've got such comprehensive tests across so much of the system. You can go and look at them all and see how they're doing it. And you can then find other places that might not be covered as well. Start by trying to write tests for that. You might get it wrong. But the worst that can happen is someone says, no, you've actually done the test wrong, and you can just adjust that to fix it up. Or you might have found a bug in the software. So you wrote the test, and then they can go, oh, thank you for showing us that there's a problem. We can go and fix it. Or you can then try to fix it and get more into the software. So the next thing I want to talk about is documentation. Most software developers absolutely hate writing anything, and they don't ever want to write documentation, and it's fine, the code just documents itself. So just go and read the code, it's all fine. Sorry to tell you that doesn't work. So when I was tutoring 2310, we said that every function had to have a comment above it to explain what the function did. That was really interesting to read what students would do. There would be some things like, it does something, and then you go, well, that's quite true, but I have no idea what that something is. And then you go and read someone else's code, and they've got a 100-line comment saying exactly what every single line in the function is doing. And you go, yeah, I didn't need to know that much detail. But at least they have thought about writing some comments. So comment your code as you're going. Like, yes, you could go back and do it all, but then it's just painful because you have to then try to work out what you were doing in that code, and trust me, you'll have a tough time working that out. So as you're going along, write comments on all your functions, and within the body if you think there's something that needs to be called out because it's confusing to someone else. If you're going to get confused by it, I can tell you now that everyone else will too. The other thing to do is write good documentation that's available for things like public APIs. So I'm sure you've all had times when you go, oh, look, there's this really cool thing, I want to go and use it. And you go and look at the documentation, and you go, I have no idea what this actually means. I don't know how to use any of this. And I wish they'd written some better docs. So just like you, they don't really want to be writing docs. They want to be writing the cool software. And I can completely understand that. But if you, when you're doing projects and you want other people to use them, you need to think about the fact that other people are not you, and they don't have access to you all the time, so they can't just come over to you and say, how do I do X thing in your product? Well, you just can't do that. So write the documentation, put it up on the web, and then people will really love you for having really good documentation. The same goes for us as a software company doing enterprise software, or anyone else doing software that's sold to clients. You'll find that the users sitting in front of it will always find unique ways of doing things, and they'll get confused by things that you think are really straightforward. To them, it's not. So what you need to do is write good user documentation. That's quite hard to do. I think as a developer, it's much harder to write good user documentation than good code documentation, because you know exactly how the thing's working in the back end, and you will gloss over things that the users don't know about. So I suggest, sure, write up a brief guide about how something should be working, but then, just like with the UI testing, give it to someone else who has never dealt with the back-end code or has very minimally touched the back-end code. Get them to go and write some documentation or tell you things that they think you need to add in, because they'll know exactly what's missing, and they'll tell you straight away, I cannot use your software because of XYZ thing. So developer documentation, really important. For example, in Tech 1, we have documentation for people to get to use our CI Anywhere product. That's really good, but me as a developer, I found that there was things that was missing, there were other things that were completely out of date, and so on. It happens all the time, I can understand that. It was also done in Google Documents, because at the time when they were changing over from SharePoint, which was not very nice, to using a proper document system like Google Documents, they decided that would be the good place to put all their API docs. However, that's not really nice for computer documentation, so we've got a Confluence license now, and I'm moving all of the documentation across. People really love you for actually paying attention to documentation, so if you want some extra brownie points, go and work in that area. The last thing that I had was around version control. Now, people all the time go, oh, yep, I've got a backup of my code. I just copied the whole folder from this place to that place, and it's good. I've got a backup now. Oh, look, I'm going to do something else. I'll make another copy. So you go and look through their file system, and you'll find that they've got program v1, program v2, program v3, program it might be working, program, oh, it actually is working. Now, sure, you've now got multiple copies of your software, and you can go back and work things out. But one thing that we've got access to as software developers are version control tools. Use them. Subversion is quite simple. Git is my go-to preference and probably a lot of yours. Since GitHub came out and everyone uses GitHub, but Mercurial is also quite good. Mercurial and Git sort of have API compatibility in many ways, so you learn one, you can use the other. So if you go and look at the different version control systems, please learn them and use them. I cannot tell you how many times I've had to deal with people who have not used version control or simply do not know how to use version control. To me, Subversion is a very simple tool to use, but we have so many students struggle with it in courses at UQ, it's quite depressing. So please go and learn it. It's not hard, because once you learn it, you'll find that it's much easier for you to keep track of your software. It's also really good for when you put it up publicly for other people to use, if it is an open source project, or if you're getting involved in open source projects, you can then easily see what everyone else has been doing. You can contribute changes back. So you need, as Russell was saying in his talk yesterday, merging back into the project. That's something that you need to learn how to do well. And if you know how to use the version controls tools, you can actually do that. So please go and learn the version control tools. And the final thing, which I don't have a slide for, is just simplicity for the user to understand your software. So at Tech One, we want our software to be as simple as possible. If you have such a simple design that anyone can use it, you don't even really need the user documentation. But you still need to do it because there will be people who can't understand exactly how to do certain things. So have the user documentation, but make the user interface as simple as possible. That goes for APIs as well. Please design your software so that anyone in the world could use it. Because if anyone can use it, then it means much less time for you having to work out bugs that people have, which may or may not be bugs because they didn't understand how to use the software. It also means much less time for support people in your company or for you acting as a support person in a project online. It's less time for you to have to deal with it if you've just done it really nicely in the first place. So that's yes, I forgot about that. One thing with version control, and let's talk about Git, are the different Git workflows. So it's all well and good to just go along, write some code, commit, write some code, commit, write some code, commit. That's great. But one thing that you can take advantage of in things like Git, and we use TFS at Tech One because we're doing all Microsoft stuff, we can do it there too. You can do it in Subversion. You can do it in any system. You can have different branches. Git makes it really easy for branches. So you just go along, oh look, I'm working on a new feature, I'll do a branch for that. It means that you can do some work down a branch, merge it back into whatever your development path is, and that way you're not necessarily breaking everyone else's code along the way. The other thing that I highly encourage you to do is have a thing such as a release branch and a development branch. If you can go along and at any time you have a completely working branch of software, which I would treat the release branch, that's really good because people will want to go and use your software. If you've done a whole lot of different things to it and you find that you've broken something in development, that's going to be a real pain for anyone else trying to do something with it. So have multiple branches. It's something that some open source projects have got really well done, others not so well done. Even personal projects, I'm guilty of it. I don't have it in all of my projects, and that's a problem for me now. So I'm just encouraging you and myself to go and follow things like the Atlassian tutorials on different workflows. Just do some research and take advantage of all the different branching capabilities and pull requests and so on capabilities of the different version control system you're using. It's going to help you a lot in the long run. So that's all I had to talk to you about today, but I thought there'd probably be some questions around that, so open the floor to any questions that you might have. Isaac?
With regards to commenting, what would you say your opinion is on when a function should be commented? For example, you have a function that might be fairly explicit in what it's actually doing in the name. Should you still comment it? It seems kind of redundant.
So the question was about commenting and how much commenting should be done. So I would personally think that you should comment as much as possible, and that is basically every function. I know that you might have a function that is so short that, and the name gives it away what it's doing. That's fine. Sometimes for that type of function, I wouldn't bother. But the thing is that while it might be really explicit to you, if I give it the code to someone else in 10 years' time, because certainly within our enterprise, our lifetime is over 10 years. So if I give it to someone in many years' time, and they're going to come and look at your code and go, why on earth is that done? If you've got a comment there explaining why you've done something, that's going to help them out a lot. So small functions, sure, you can probably get away with it, but the majority of functions you should be commenting. Even within those functions, I would have lots of comments if it's bits that you think someone else will struggle to understand. So at Tech One, and most projects, you get someone else to review your code. If that person cannot understand what's actually happening, that means that you have done something really bad or you have not put enough comments in. So if they can't understand it, you need a lot more commenting and or to fix the function in the first place. So think about that as you're developing, and you'll probably work out fairly quickly what a good ratio is. The other thing to do is look at some of the open source projects. You need to find good ones in that area. Not every open source project is a good example of commenting, but there are some that are very good. Go and look at those ones, the really established ones, and they've normally got a decent amount of commenting that allows you to work out, like for that project, what's required. For your own stuff, that's up to you. Yes? So yes, there could be certainly privacy concerns around that. So obviously pages like that are only available to certain people within the company at the time. So it's available at the moment publicly for me to access it today, but normally I can't even get to it without being in the building. So yes, there are certainly concerns around that. Most of the things that we're actually logging, you can't get information out of it. So we might have, okay, well, this particular client was trying to save this entity, and it was going through this path in the software, but we're not really logging all of the details of the particular request being made. So yes, the SQL statements will probably have identifying information in them, but I don't normally see those SQL statements. I know that they will run, but I don't see them all the time. If it's in my development environment, sure, I can see everything. But in the cloud, it has to be locked down because we don't want people to see it. And that's something that they're currently working on, work out exactly how much they can deal with and how much they shouldn't be touching and so on. Yes? For the logging? Oh, okay. So within Technology One for the CI Anyway product, we've actually been backwards compatible with databases since the very first version of our product 27 years ago. So that means that the very first customer who got a database, obviously they've upgraded the database software, but the actual tables themselves have not been changed. You cannot delete a table, you cannot delete columns, you can't change data types, etc. You could make a column bigger, but you can't shrink them and so on. So that means that we do relational databases. We support Oracle and Microsoft SQL Server. We're also doing Postgres stuff at the moment, and that should be online within the next 12 months, I'm pretty sure. So it's basically relational databases. So if you can do relational databases, I really didn't do much of that at uni, and I've come to Tech One and had to do a lot of database stuff, and I'm probably worse off for not having done courses earlier. But luckily, within software, there are so many resources available out there you can go and learn. So please go and do that as you go along. Another question? Yeah. So we certainly have audit logs for certain entities. We don't have audits for every single possible thing because some of them, there's not really much point on having it. And each product, probably a bad thing, but each product it's at their discretion as to the auditability of that particular thing. We have generic functions available for anyone to say, okay, well, just audit this, and it will just go and do that for you. But I, as a developer, don't use that audit trace that much. I'm not sure how much customers have because I haven't dealt with that side of things too much yet in my what is it now? Nearly 9 months at Tech One. But I know it certainly exists. I couldn't tell you how much exactly. Yes?
What sort of code coverage do you think each project should have, and at what point does that code coverage get too much?
Or I think you should be covering every single possible thing. If you want to make sure that something is actually working exactly how you want it to, you need to cover every single code path. So, thank you, Russell. If you don't cover every single possible branch, you will have problems whereby you think that something's going to work and you'll find some case where it just simply does not. And even when you're writing things, you might have your code coverage tool say that you have got 100% covered, but there can still be cases where you have not thought of it and the particular test you're doing will not trigger something. So it's really hard to write really good tests. That's why lots of companies have got people who are just dedicated to writing the tests. They're not writing the software as much as just doing testing. At Tech One, we don't have enough people writing tests, to put it very simply. We have all of the product teams working on their particular applications. At the moment, that's mainly based around converting everything from our old CI product to CI Anywhere, so that we can have every customer move across to the new platform. And because of that, some things like the code coverage I've noticed has slipped off a bit. So we need to encourage everyone at Tech One to do more testing. I personally need to do a lot more testing on my code. I know that there's stuff in there. If I brought up other bits of my code, you'll see that there's big red circles, and I need to tell myself to go and do more. And as developers, you don't want to be writing tests. You quite simply just want to be writing all the cool software. But it's so important to have as much code coverage as you possibly can. Just write the tests the whole way. Yes, Russell?
So just adding to that, the tests are not to prove that your code works. I mean, that is a useful purpose for it. It is important to prove that your code works. The reason you write tests is to prove that your code keeps working.
Yeah.
10 years' time, someone's going to come back to this code base and say, oh, I'll just make this small change. And all of a sudden, they're discovered your entire test suite failed because your entire code base depends upon that string starting with a particular character or whatever the hell the change happens to be. You don't write tests for now. You're writing tests for tomorrow. So
Yeah.
when those changes start happening, you know in advance what's being broken.
Yeah. And following on from that, if you're doing refactoring of code, because you always like to do that, if you can have tests written for that code before you refactor it, that's the way you want to do it. Test-driven development is always talked about at universities. I haven't really seen much of that done in practice. I think people should think about doing it in practice. But certainly for refactoring, if you have not got tests for all the stuff that you're touching in that code base, you are going to have problems. Very simply. There will be some mistake that you have made in the refactoring. So go and write as many tests as you possibly can think of, and get, if it's user interface stuff, go and get people to play around with every single point that you've changed to make sure that it actually works. Yes? The level of database normalization, I haven't really looked across that many database tables in our entire company database schema. I've looked at some of the ones in our apps, because each person is put onto a team doing certain apps, so I've looked at those ones. We generally don't want to, you want to keep it as simple as possible. You don't want to have it like thousands of columns in some database table, and you don't want to just... So, sure, some of our database tables at Tech One are quite large, and some of that comes down to performance things. So if we're trying to load up some record that's got a huge amount of data and it's got lots of child tables, yes, you can write really good SQL to make that fast, but sometimes it's really difficult to get that going the way you want it to. So sometimes we do have some duplication of data from this table to that table just to make things work so much simpler. That's not necessarily a good thing, but sometimes that's necessary. Russell? That's a good point. Does that sort of answer that question? Yep, okay. Any other questions around this? Take one, Joel? Yep. So the particular project that used F# was that, I think there's more than just that particular code coverage graphing one. So mainly that was done by a couple of people who are interested in learning functional programming. So it's quite encouraged for anyone to go off and learn anything they want to. Don't expect that to necessarily make it into the shipped product code, but certainly go and learn whatever you want. So in this case, a developer wanted to learn F#, learn functional programming, where Microsoft, so F# seems a good choice just for now. So he went and wrote this particular code coverage tool, and I don't know how long it took him, but certainly it's there now. He's actually left the company, but I picked it up the other day because it was broken, so I'm now learning functional programming, and I have no idea what I'm doing yet, but I'll learn along the way. Anything else at all? Yep. Okay, so the question was, do you want to do validation on both client side and the web browser or similar, as well as in the business layer in the server? Do you have a common library? Well, no, not really, because in all of the server-side stuff, that's C#. On the client side, it's all JavaScript. So doing the validation in both, unless we're using something like Node.js where we can share some common files between two areas, it's a bit hard to do that. But in saying that, there are also ways you could do validation whereby quite a lot of our screens, if you are changing data, AJAX calls are often, if you've got a good setup, they're quite quick. So you can put it across to the server, bring stuff back with validation if it's complicated. Other simple stuff like checking the number of decimal places in a number or something, do that client side. It's really quick and simple to do. So we have within Tech1 CI Anywhere, we've got a core platform which provides all of the generic functions for things like validation as well as all the product screens. So that gets tested there. All of the individual product apps then take that into their own app to use. So that way we've got one common set of validation, common set of all the database logic and so forth. That's shared across every single application. And then all the application has to do is implement the individual database tables and logic around a particular entity, and then they get the screens for free, basically, and validation in a lot of areas for free. Yes, you will have to do your own validation of particular parts of your product, but if you do as much of that in the business layer, you can still do things like, okay, well, there's an error here. We will pass that back to the user and tell them to fix it up later on. So do it in both places, but have the most strong validation in the logic on the server. Yes. I couldn't tell you exactly what size. I haven't actually seen a client database because, quite simply, I shouldn't be seeing client databases. So I couldn't tell you exactly how big one is. I imagine they would be rather large, especially when you've got products across lots of different areas that we go into. So we have so many different marketplaces. Each of them have got all of their own tables and lots of data. So I imagine they would be really large databases, but I couldn't tell you exactly how big. Yep. Yep, okay, so what's the structure of Tech 1? We have two sides to the development structure in Tech 1. There is support and enhance, which is supporting all of the old software and doing new pieces of functionality as customers need it, like small improvements. We've then got the R&D side, which is all of the new software that we're developing, CI Anywhere. So I'm on the CI Anywhere team. Anyone who starts as a graduate or intern goes into the CI Anywhere side. And the way we structure that is we have individual product teams, which are fairly small. So my team has got a system architect who is in charge of all of the products within our particular team. We've then got developers. So there are, let's see, when I started, there were 3 developers, including myself. We've now got a couple of extras who are doing individual special projects. Each team is quite small like that, so you know everyone on your team quite well because it is so small. And then we've got a tester and a business analyst. So the business analyst's job is to go and work out what customers are wanting, write up things like the user stories and requirements for each task that we're given to work on as developers. You've also got project managers, so they might manage your team plus a couple of other teams. You've also got product owners who are going to cover the entire team, product base, and they'll be dealing with customers as well. And then it goes up from there. So if you came to Tech 1, you'd be working on a pretty small team. So to me, it doesn't feel like some big monolithic company that I get lost in. I can go and speak to anyone on any team at any time, because most of the people are there in Brisbane. If they're not, we've got chat. We just go and talk to that person, and you can easily ask them a question. So that's for our Perth team or Sydney team or whatever else. Yeah. Yes, 2-week sprints for most teams. Each team can do their stuff slightly differently because it's up to them. But yeah, generally 2-week sprints, and you won't always see a release at the end of those 2 weeks, but there'll be some core bit of functionality that's there, that's wrapped up, and then we'll move on to the next bit. Yeah. The reason for not doing releases every 2 weeks is because as an enterprise software company, our customers don't want to be doing big installations all the time. So taking an update is a really big chore for them. Test, so on, release. So yeah, we do probably, our team is aiming for every 2 months to release. Other teams have certain other targets. Yes. Certainly does work at the end of 2 weeks. If it's not working at every single check-in, there's a problem in development. So we should be able to run up a development environment, and that will work. I know there are certainly cases where it doesn't, but that person then needs to go and fix it straight away. Yes?
How are your development environment set up? Do you have like a central repository everyone can pull down and they just set up a dev environment like that?
Yep, so our setup is basically, there is one TFS server, so Team Foundation server. That's used for all of the source code within the organization. So there's a section that is CI Anywhere. All the code's in there. Any developer in CI Anywhere can get to it. So I could pull down another team's code. I shouldn't be checking anything in to that, obviously. And we probably need a few more restrictions around who can check in what, when. But in general, people are pretty good in, okay, this is our team stuff, and I'll just do stuff in that area. But we can then see all the other teams. All of our development's done in an EC2 instance on Amazon's Sydney area. So that means that at work, I have a little box. I could even right now, in fact, I'm logged into it at the moment. I can then log into my team's server. So each team has got a server at EC2 that's got Visual Studio on it. All the stuff's done in there. So that means we can work anywhere on our code at any time. As Matt was sort of saying yesterday, they got rid of all the big desktop machines to do all your local compilation and replace that with a small box on your desk and 3 monitors. So it's a lot cheaper for them now because we like our lots of monitors because we can have development environment, browsers, development tools, and so on. And it's all pretty fast. I thought running everything in the cloud would be quite slow. Occasionally, yes, the network does drop out, and that means the entire floor cannot do anything. But in the time that I've been there, that's happened twice. So, and it was only for half an hour at the maximum. So I think that's pretty good so far. And the speed really hasn't been an issue. Some teams have complained about speed, but we just got bigger boxes and then the problem was fixed. So if there's no other questions, I'll wrap it up there. I'm here for the rest of the conference, so come and speak to me if you've got any questions. We'll be at the Careers Fair this afternoon as well. So I hope that was useful, and please take away some of those tips, because if you do all of them, then employers and open source projects will really love you. Thank you.